So today we'll be solving inequalities, okay? So as I mentioned before, we've dealt with this before a little bit. Who remembers how to solve inequalities? It's really the same as solving equations, except what? You gotta remember one thing. 3 people, that's it? Remember? Okay, how about Carly? You remember?
When you divide or multiply by a negative number, you have to switch the inequality.
That's right. It's the same exact, you do the same exact way as solving equation, except when you multiply or divide by a negative number, what do you do with the inequality symbol? You reverse. That's it. Everything else is the same. You guys remember this? So let's take a look at the first example here. X minus 7 less than or equal to, thank you, 16. So go ahead and everybody solve. It should be really straightforward. This time, do you think the inequality symbol will be reversed at all? No. Okay, you'll be just adding and subtracting. It doesn't reverse at all. Only time again is if you divide or multiply by a negative number, right? Okay, go ahead, everybody. Finish. It should be pretty straightforward. Okay, so Claire, what do we get? What do we do to get x by itself? We
Add 7.
correct. And so how many people got x is less than or equal to 23? Okay, very good. Okay, now is it a good idea to write 23 greater than or equal to x?
No.
No. Why not? No, it's not wrong to write this, but yes. No, it's the same. Actually, it's the same equation. This is actually okay. So you don't want to write it this way. It's not wrong. Okay, fine. Here I will. It's okay to write this, but it's not a good idea. You want to write x on the left side first. Christina?
Because x, if you have x versus in standard form.
Standard form, kind of, yeah. And not only that, somebody read this on the one on the left side. Yeah.
X is less than or equal to 23.
Okay. Somebody read one on the right. Yeah, Chuck.
23 is greater than or equal to, or greater than or equal to x.
Yeah, but what are we really looking for? We're looking for the value of x. Which one of these will tell you the value of x? A little bit more clear. One on the left, because if you say 23 is greater than or equal to x, it's kind of you're not really sure what x is. Does that make sense? So even if it's written this way, you should rewrite it with x on the left side first, right? Because what are all the values? How many solutions do I have for this? How many x? Wait, what are your solutions? How many solutions would make this would be true for this inequality? X less than or equal to 23. How many numbers do you know that are less than or equal to 23? Infinitely many of them, right? So here's how you write this as a sentence. This is what you need to write. So on your homework, I want you to write it this way. The real numbers less than or equal to 23. That's my solution, is that right? That's what this inequality is saying. X less than or equal to 23, right, means the real numbers that are less than or equal to 23. Again, if you write it as 23 greater than or equal to x, it's sort of confusing as to what x could be, right? It's much clearer having x on the left side. Does that make sense? And of course, we know how to write this as a graph, don't we? Isn't this the graph we get? We got 23 there, and then everything on the left side of it. How come there isn't a closed circle at 23? Why isn't it open circle? Yes? Yeah, because it says x is less than or equal to. What if it was just less than 23? X is less than 23. What? Yeah, you would have an open circle. Does that make sense? You guys remember this? Okay, so go ahead. All right. So please have the x first. Okay, you want to have x on the left side. Okay, not on the right side. It's a lot clearer when the x is on the left side. Okay, take a look at example 2. It says p over negative 13 is less than 3. So again, we want to solve for p. What should we do to solve for p, to get the p by itself? Chuck?
Multiply negative 13 to both sides.
That's correct. You need to multiply negative 13 to both sides. And of course, when I do this, Matthew, what happens to the inequality symbol? It switches. You're right. So go ahead. You multiply both sides by negative 13. Go ahead, finish it up and write down as a sentence, like as I did it with the set notation. Okay, that's how you write them as a sentence. Okay, and then I want you to graph it. I'll wait. Everybody try. All right. How about Royce? Tell me what to write.
P is greater than negative 39.
Good. Negative 39 is correct. How many people remember to reverse the inequality symbol? Very good. Okay. Why do we reverse this time? Because we're multiplying by a negative number. What if we multiply both sides by a positive number? Do we reverse? No. Okay, very good. And so also, did you write this SSN notation, the real number is greater than negative 39 that way. Okay, good. And here's the graph. Now, how come this time there's an open circle at negative 39? Yeah, because it says strictly, it just says greater than negative 39. So is negative 39 part of our solution? No. Is it? What about negative 38?
No. Yes. No.
Yes.
Is negative 38 our solution, part of our solution?
Yeah.
Yes. What about negative 38.9999?
Yeah.
Yes, it is. But not negative 39. Does that make sense? What about 1 million? Is that part of our solution?
Yes.
Yeah, it's everything on the right side of negative 39. Isn't 1 million, like, if you keep on going, right? Okay. What about 0? Is 0 our solution?
Of course, yes.
Oh yes.
Okay, what about negative 40?
No.
No. What about negative 39.1? No. Do you understand? Okay. So that's what this is. Negative 39.1 will be on the left side of negative 39, right? Yeah. Negative 39.1 will be on the left side of negative 39. It's not part of it. Okay. So let's think about why we need to reverse the inequality symbol when we multiply or divide both sides by negative. Okay. So take a look at what we have here. Is this true? 2 less than 3.
Yes.
Of course it's true. 2 is less than 3, right? Now, what happens if I were to multiply both sides by negative 1? What do you get on the left side? It becomes negative. If I multiply both sides by negative 1, I get negative 2, and then what do I get on the right side? Negative 3. Now, which one is greater? Negative 2 or negative 3?
Negative 2.
Negative 2. You see, if I don't reverse it, right? If I don't reverse it, the statement will be false. Does that make sense?
So clever.
Does that make sense? Do you see why we need to reverse? Okay. Right? This is same example if I were to divide both sides by negative 1. You see the same thing would happen. Does that make sense? What if I had this then? Maybe some of you may say, oh, it might have worked because they're both positive. But what if I have negative 2 and 3? Is negative 2 less than 3? Is negative 2 less than 3? Yes. Okay, so this is a true statement, right? Negative 2 less than 3, correct? What would happen if I multiply both sides by negative 1? What do I get on the left side? How about Spencer? I get 2. On the right side, what do I get? Negative 3. Okay, so if I get 2 on the left side and then negative 3 on the right side, what's greater? 2 or negative 3? 2. Do you see why we have to reverse? If you didn't reverse, right, it'll be wrong. The statement will be wrong. Does that make sense? And obviously, if you multiply both sides by a positive number, does it reverse? No. Whatever that was greater, it would be still greater, right? If you multiply both sides by positive. Anyway, let's move on. Look at this one here. What if they were both negative? Is negative 2 greater than negative 3, guys?
Yes.
Okay, let's multiply both sides by negative 1. What do I get on the left side? Chuck?
2.
2. What do I get on the right side?
3.
3. So could I keep the inequality this way? No. If you do, then it'd be wrong, right? You have to say 2 is less than 3. Does that make sense? So I showed you a case where they're both positive. One of them is negative. The other is, right? They're both negative and so on. You see how it works out? Okay. Some of you say, what if we then divide? Would it work? Would we divide? Well, let's look at it. 2 less than 4. Let's divide both sides by 2. Negative 2. Okay. What would happen if I divide both sides by negative 2? On the left side, what do we get? We get negative 1. On the right side, what do we get? Negative 2. Which one's greater? You see why we have to reverse? Okay. Do you guys get the idea? What happens if we multiply both sides by, of course, positive numbers? Like 2 greater than 4. The right side will still be greater, right? Do you see how if I have 2 less than 4, if I want to multiply both sides by a positive number, it doesn't really change? What if I divide both sides by a positive number? Does that change the inequality? No. 2 less than 4, right? What happens if you divide both sides by positive 2? You still get left side is what? What's left side, guys? Left side, you get positive 1. Right side is positive 2, right? So, is the right side still greater?
Yes.
Does that make sense? So that when you multiply or divide by a positive number, the inequality stays the same, right? Because whatever that was greater still remains greater. But if you divide or multiply both sides by negative, then it reverses, does it not? Okay. What about for addition and subtraction? It doesn't really change much, does it? If you add or subtract both sides of an inequality, like for example, let's say this is left side is smaller, and then the right side is greater. Right, if it's like this, if you were to subtract both sides by the same number, does the greater side become smaller side? Does it? In other words, okay, here. Let's say we have a look. Let's say we have a like here something greater over here and small, and we have a pendulum, right? On the left side is heavier, right? If you were to add both sides by same amount, will the right side ever be heavier than left side?
No.
No. If you were to subtract, okay, same amount from both sides, would the right side ever be heavier than the left side? No, because you are adding same amount to both, or you're subtracting same amount. Whatever that was greater still remains greater. Does that make sense? Well, addition and subtraction is pretty easy to see, but for multiplication and division, it's kind of nice to see an example, right? Like this. If you were to multiply or divide by a negative number, you gotta reverse the inequality symbol. Otherwise, right, you have wrong statement. Okay. All right. Let's do some. All right. Take a look at example 3. I have a plus 4 less than a plus 1. Okay. So everybody go ahead and try this, okay? And tell me, write down the solution, okay? And then graph it. Go ahead, everybody try it. I'll wait. So this one's kind of interesting. Okay, so Christina, what do I do to get a by itself?
We subtract a.
Yeah, I subtract a from both sides, right? You're gonna gather the like terms. When you do we reverse inequality at all? No, it stays the same.
And they cancel out.
Yeah.
And then it's 4 is less than 1.
Good. So we get 4 less than 1. By the way, someone said it. Is this true?
No.
No, 4 of course not is not less than 1. 4 is greater than 1. So then what do we write for our solution? Yeah, no solution is right. Okay, so, right, that's what we write down for no solution. Now, for a graph, what are you going to do for a graph? How are you going to graph this? Yes.
Wait, I just have a question.
Yeah, hold on. Let me finish this. How do we graph this? On a number line, what are you going to do?
Put a dot.
Do nothing. No, if you put a dot, then that's your solution. So on a number line, you don't do anything, right? For no solution, there's nothing that, right, works. So what does it mean when we say no solution?
Nothing.
There's no number that you could plug in for
A.
that will make this inequality true, right? As you can see, left side is always going to be, right, bigger than the right side, no matter what you plug in for A. So there's no number you could plug in here that will make it true. Does that make sense? Yes? Okay. So some of you are asking this. Take a look at example 3b. I now have a plus 4 greater than a plus 1. What do you think would happen on this case? Go ahead, everybody try. I'll wait for you. All right, here we go. Samara, what do I do for this one? Yeah, subtract a, right? Oh, I forgot to put negative. Oops. Okay, so then we get 4 greater than 1, don't I? Okay, so is this true? Yeah. What's your solution? Yeah, all real numbers. How do you graph all real numbers? Yeah. Yeah, everything on the number line is your solution. So what does it mean when we get all real numbers as our solution? Yes, Libby? Yeah, you could plug in any number for A. Will always be true. This inequality will always be true because right side is already greater than left side, right? You could plug because A, right, are on both sides, same amount of A. So no matter what you plug in for A, this is always going to be true, right? Easy enough. Okay, so just like equations, when we solve equations, sometimes you get no solution, sometimes you get all real numbers as a solution for inequalities as well. Okay, are we okay with that? Now let's move on. Okay. All right, then everybody go ahead and try example 4. Sometimes, the variables will be on left side of they will be on both sides of inequality, right? Symbol, just like equations, right? So you have to gather them and then solve. I'll wait, finish it up, write down, right, as a sentence in a set notation and also graph it, okay, after you solve. I'll wait, everybody try. All right, Kevin, what do I do here?
You subtract 16x.
Good. I will subtract 16x, right? Yes. Could I subtract 7x both sides? Yeah, but then you gotta move the number around, right? So let's just subtract 16x from both sides. How many of you got negative 9x greater than negative 18? Good. Mimi, what do I do next? Good. Divide both sides by negative 9. Claire, would the inequality switch or no? Okay, but answer this question first. Would the inequality switch if you divide both sides by negative 9? You don't think so? We're dividing by.
Oh, you said divide. Yes, that makes sense.
So they do switch, right?
Yes.
So we get x is now less than or equal to 2. Oh, oh yeah. Sorry, it's my bad. It's not there. Okay, so did you get this?
Yes.
The real number is less than 2, and you see why we have an open circle at 2? Because we do not include 2. Was that your question? Okay, sorry. Okay, there you go. Any questions? Does that make sense? Easy enough?
Yeah.
All right, good. Let's move on to the next one. Example 5. 5 minus 3 times x plus 2 less than or equal to 6. I put a star on this one because people make silly mistakes on this type of question. We talked about this before also, but let's see if you guys remember. I'm not going to say anything. Everybody go ahead and try. I'll wait. Okay, good. If you remember, that's good. Okay, go ahead, everybody try. I'll wait. All right, so did anybody do 5 minus 3 first? No? Isn't that easier to do that? Shouldn't we do that first, guys? That's easy. Oh, you're right. Because if you do that, you get it wrong. How come we don't do 5 minus 3 first? Who remembers? How about Eric?
You have to do the one in the parentheses.
Yes, you got to multiply first before you subtract. You guys remember? Order of operation. Okay, just because you see something that's easy doesn't mean you got to do that one first, right? If you do this, in this case, you get it wrong. Here's subtraction. We have a multiplication here. You got to distribute -3, right? Camilla, tell me what to write. Good. So you get 5 minus 3x minus 6 is less than or equal to 6. Of course, on the left side, you should always simplify. You get -3x minus 1, right? Less than or equal to 1. And of course, we add both sides by 1. We get -3x less than or equal to 7. Now we divide both sides by -3. Kevin, what do we get when we divide by -3?
You get x is greater than or equal to -7/3.
Good. You reverse the inequality and then it becomes -7/3. And do we know how to write this as a sentence? As a set notation? What do you write? The real numbers greater than or equal to -7/3. And of course, you know how to graph that. It's on the right side of it, right? Every number that is greater than -7/3 will be on the right side of -7/3. And do you see why it's closed out there?
Because equal to.
Yeah, it says greater than or equal to. So we include the -7/3. Easy enough? Okay. Let's do one last one here. Here we go. So here's example 3. 3 over 8y plus 1 greater than or equal to 9 over 8. Okay, so example 6, it's really the same as before, except now we have some denominators and so on. We got fractions. So how do we deal with fractions? Just like equations, we should multiply both sides by the reciprocal? LCD. Right? We want to multiply both sides by the LCD. This time the LCD is simply 8. Okay, because we have this common denominator. Go ahead, everybody finish it up. I'll wait. Okay. Oh. Alright, Angel, what do we do here? Multiply both sides by 8. Okay, so when we do, Eric, tell me what to write.
Me?
Yeah.
3y plus 8. Right?
Yes?
It's greater than or equal to 9.
Good, 9. Okay, you see how easy this becomes? Alright, Samuel, then what do I do next? Subtract 8 from both sides. Do we reverse the inequality symbol here?
Not yet.
No, we're subtracting 8. We're not multiplying or dividing by negative. Okay. So then we divide both sides by 3. How many people got the real numbers greater than or equal to 1/3? Good. Did you all get this graph?
Yes.
Is this easy? Can you do something like this for your homework tonight? Yes? Good.